Hello dear students. In the last video, we have seen monotonic sequences and some important theorems on monotonic sequences. In this video, we shall see some standard sequences. You have 4 standard sequences. Let us see one by one. First standard sequence is x power n. X power n where x is real number. We discuss the nature of this sequence in 3 different cases. Case 1 when mod x less than 1. Case 2 when mod x is equal to 1 and case 3 when x greater than 1. Let us see the different cases. Case 1 when mod x less than 1, that is nothing but x lies between minus 1 and 1. See, if x is equal to 0, x is equal to 0 also come in this interval. So when x is equal to 0, x power n is also equal to 0. And limit n tends to infinity, x power n is also equal to 0. As 0 is finite and unique, if x is equal to 0, sequence x power n is convergent. Let us see the case when x not equal to 0 for the remaining values in this interval, for the non-zero values in this interval. Since mod x is less than 1, 1 over mod x is greater than 1, right? Now put 1 over mod x is equal to 1 plus h, where h greater than 0. Since 1 by mod x is greater than 1, h should be greater than 0. Idrud reciprocal ತಗೋಣ ಇವಾಗ. That implies mod x is equal to 1 divided by 1 plus h. ಇದಕ್ಕೆ ಪವರ್ n ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ ಎರಡು ಸೈಡು ನಾನು ಇವಾಗ. That gives mod x power n is equal to 1 divided by 1 plus h whole to the power n. ಇಲ್ಲಿ ಇವಾಗ ಏನು ಮಾಡೋಣ ಅಂದರೆ ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈ ಡಿನಾಮಿನೇಟರ್ ಫ್ಯಾಕ್ಟರ್ನ ಬಿಡಿಸ್ಕೊಳ್ಳೋಣ. ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಎಲ್ಲ ನೀವು ಓದಿದ್ದೀರಾ, ನಿಮಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತು ಇದನ್ನು ಹೆಂಗೆ ಬಿಡಿಸ್ಬೇಕು ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಅಂತೇಳಿ. ಆದರೂ ನಾನು ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಕೊಡ್ತೀನಿ ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಏನು ಹೇಳುತ್ತೆ ಅನ್ನೋದನ್ನು. ಎಕ್ಸ್ ಪ್ಲಸ್ ಎ ಹೋಲ್ ಟು ದಿ ಪವರ್ ಎನ್. ಎಕ್ಸ್ಪಾನ್ಷನ್ ಆಫ್ ದಿಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಈಸ್ ಎನ್ ಸಿ ನಾಟ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಪ್ಲಸ್ ಎನ್ ಸಿ 1 ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಮೈನಸ್ 1 ಎ plus nc2 x power n minus 2 a square plus etc plus ncn a power n. ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇದನ್ನು ಬಿಡಿಸೋಣಂತೆ ಇವಾಗ. 1 plus h whole to the power n ಬಿಡಿಸೋಣಂತೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್, ಎಕ್ಸ್ಪಾನ್ಷನ್ ಆಫ್ ದಿಸ್ ಇಸ್ nc0 plus nc1h plus nc2h square plus etc plus ncn h power n, right? But what is nc0 and ncn? nc0 is equal to 1 and ncn is equal to 1. ನಿಮಗದು ಫಾರ್ಮುಲಾ ಗೊತ್ತಲ್ಲ. ncr is given by n factorial divided by n minus r factorial into r factorial. ncr is given by this equation. ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನೀವು nc0 ಕಂಡುಹಿಡಿದ್ರೆ 1 ಸಿಗುತ್ತೆ, ಅದೇ ಥರ ncn ಕಂಡುಹಿಡಿದ್ರೂ 1 ಸಿಗುತ್ತೆ, ಹೌದಾ? ಸೊ ಈಗ ಬರಿತಾ ಹೋಗೋಣ. ಬೈನಾಮಿಯಲ್ ಕೋಯಿಫಿಷಿಯೆಂಟ್ಸ್ ಏನಿದೆಯೋ ಅದ್ರ ವ್ಯಾಲ್ಯೂಸ್ನ ಬರಿತಾ ಹೋಗೋಣ. ನ್ಯೂಮರೇಟರ್ 1 ಇತ್ತು, ಡಿನಾಮಿನೇಟರ್ nc0 ವ್ಯಾಲ್ಯೂ 1 ಪ್ಲಸ್ nc1 ಇತ್ತಲ್ಲ, nc1 ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ n, nc1 ವ್ಯಾಲ್ಯೂ n 1 ತೋರಿಸ್ತೀನಿ ನೋಡ್ರಿ ಬೇಕಾದ್ರೆ ನಾನು. nc1 which is n factorial divided by n minus 1 factorial into 1 factorial, right? 1 factorial. n factorial divided by n minus r factorial into r factorial ಅಲ್ಲ. ಸೊ n factorial divided by n minus 1 factorial into 1 factorial. Now this is equal to 1 factorial in n 1 factorial in n 1 ಡಿನಾಮಿನೇಟರ್ n minus 1 factorial ಇದೆ, ನ್ಯೂಮರೇಟರ್ n factorial ಇದೆ. n factorialನ ಬೇಕಾದರೆ ನಾವು ಏನಂತ ಬರಿಬೋದು, n into n minus 1 factorial ಅಂತ ಬರಿಬೋದು. ಡಿನಾಮಿನೇಟ್ರಲ್ಲಿ n minus 1 factorial ಇದೆ. n minus 1 factorial ಕ್ಯಾನ್ಸಲ್ ಆಗೋ ಥರನೇ ನಾನು ನ್ಯೂಮರೇಟರ್ ಫ್ಯಾಕ್ಟೋರಿಯಲ್ ಟರ್ಮ್ನ ಬಿಡಿಸ್ಕೊಂಡಿದ್ದೀನಿ. n minus 1 factorial ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಇವಾಗ ಏನು ಉಳಿತು, n ಉಳಿತು. ಸೊ nc1 ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ n, ಅದ್ರದ್ದು ಬರ್ದಿದ್ದೀನಿ ಇಲ್ಲಿ. ನೀವು ಇದೇ ಥರ ಫಾರ್ಮುಲಾ ಹಾಕಿ ಬಿಡಿಸಿದ್ರೆ nc2 ನಿಮಗೆ ಏನು ಸಿಗುತ್ತಪ್ಪ, nc2 n ಇಂಟು n ಮೈನಸ್ 1 ಡಿವೈಡೆಡ್ ಬೈ 2 ಫ್ಯಾಕ್ಟೋರಿಯಲ್ ಸಿಗುತ್ತೆ, ರೈಟ್? ಇಂಟು h ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎಕ್ಸೆಟ್ರಾ ಪ್ಲಸ್ ncn ಇತ್ತಲ್ಲ ಲಾಸ್ಟ್ ಟರ್ಮಲ್ಲಿ, ncn ವ್ಯಾಲ್ಯೂ 1 ಇಂಟು h ಪವರ್ n. ಸೊ ಬೈನಾಮಿಯಲ್ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಡಿನಾಮಿನೇಟರ್ 1 ಪ್ಲಸ್ h ಹೋಲ್ ಪವರ್ n ಅನ್ನು ಈ ರೀತಿ ಬಿಡಿಸಿದ್ದೀವಿ, ರೈಟ್? Now this term is obviously less than 1 divided by nh. This is obviously less than 1 divided by nh. So now mod x power n is less than 1 divided by nh, which is less than epsilon for all nh greater than 1 by epsilon. ಬರಿಬೋದಾ? Whenever nh is greater than 1 by epsilon, 1 by nh is less than epsilon, right? Now this implies n is greater than 1 by h epsilon. h ಈ ಕಡೆ ತಗೊಂಡಿದ್ದೇವೆ. n is greater than 1 by h epsilon. So now what we have? Mod x power n is less than 1 by nh, which is less than epsilon for all n greater than 1 by h epsilon, right? Now choose m to be nearest positive integer which is less than 1 by h epsilon. Then mod x power n is less than epsilon for all n greater than or equal to m. ನೀವು ಎಮ್ಮನ್ನು ಯಾವ ರೀತಿ ಚೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಪ್ಪ ಅಂದರೆ, ಇಟ್ ಶುಡ್ ಬಿ ನಿಯರ್ ಟು 1 ಬೈ ಎಚ್ ಎಪ್ಸಲಾನ್, ಎಮ್ ಶುಡ್ ಬಿ ನಿಯರ್ ಟು 1 ಬೈ ಎಚ್ ಎಪ್ಸಲಾನ್ ಆ್ಯಂಡ್ ಇಟ್ ಶುಡ್ ಬಿ ಲೆಸ್ ದೆನ್ 1 ಬೈ ಎಚ್ ಎಪ್ಸಲಾನ್. ದೆನ್ ಎನ್ ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಎಮ್. Therefore mod x power n is less than epsilon for all n greater than or equal to m. ಈ ಮಾಡ್ಲಸ್ ಒಳಗಡೆ x power n ಮಾತ್ರ ಇದೆ. x power n ಅನ್ನು ಬೇಕಾದ್ರೆ ನೀವು x power n minus 0 ಅಂತ ಬರ್ಕೋಬೋದಲ್ಲ. ಸೊ ಮಾಡ್ಲಸ್ ಆಫ್ x power n minus 0 is less than epsilon for all n greater than or equal to m. Now by the definition, limit n tends to infinity x power n is equal to 0, where mod x is less than 1. Now see, x power n is converging to the point 0. Sequence x power n is convergent. ಸೊ ಎಕ್ಸ್ 0 ಆದಾಗೂ ಸೀಕ್ವೆನ್ಸ್ ಕನ್ವರ್ಜೆಂಟ್ ಆಯಿತು, ಎಕ್ಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ತಗೊಂಡ್ರೂ ಸೀಕ್ವೆನ್ಸ್ ಕನ್ವರ್ಜೆಂಟ್ ಆಯಿತು. ಸೊ ಫಸ್ಟ್ ಕೇಸ್ ಅಂದರೆ ಮಾಡ್ ಎಕ್ಸ್ ಲೆಸ್ ದೆನ್ 1 ಇದ್ದಾಗ ಒಟ್ಟಾರೆ ಸೀಕ್ವೆನ್ಸ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಏನಾಗುತ್ತೆ, ಕನ್ವರ್ಜೆಂಟ್ ಆಗುತ್ತೆ. ಲೆಟ್ ಅಸ್ ಸಿ ದ ಸೆಕೆಂಡ್ ಕೇಸ್. ವೆನ್ ಮಾಡ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1. When mod x is equal to 1. Mod x is equal to 1 implies x is equal to plus or minus 1. X has two values. Let us see when x is equal to 1. When x is equal to 1, x power n is equal to 1 power n and 1 power n is 1. Limit n tends to infinity x power n is equal to limit n tends to infinity 1 power n which is equal to 1. So the sequence x power n is convergent. This is a simple case. When x is equal to 1, sequence x power n is convergent. Let us see what happens when x is equal to minus 1. When x is equal to minus 1, x power n is equal to minus 1 to the power n. And we know that minus 1 to the power n goes to minus 1 as n is odd, and minus 1 to the power n goes to plus 1 when n is even. So the sequence oscillates between two finite values, that is minus 1 and 1. So when x is equal to minus 1, sequence x power n is oscillatory. So in the second case, the sequence x power n converges when x is equal to 1 and it oscillates when x is equal to minus 1. Let us see the third case. When x greater than 1. Take x is equal to 1 plus h where h is positive. Since x should be greater than 1, this should be positive. Now x is equal to 1 plus h. Apply power n on both sides. X power n is equal to 1 plus h whole power n. Now binomial theorem. According to binomial theorem, 1 plus h whole to the power n is equal to 1 plus nh plus n into n minus 1 by 2 factorial into h square plus etc. plus h power n, which is obviously greater than or equal to 1 plus nh. This whole sum starting from 1 up to h power n, this whole sum is obviously greater than or equal to sum of two terms, right? 1 plus nh. 1 plus nh goes to infinity as n goes to infinity. So x power n goes to infinity as n goes to infinity. As n goes to infinity, 1 plus nh goes to infinity. Therefore x power n goes to infinity as n goes to infinity. That means sequence x power n diverges to infinity when x greater than 1. So what we can conclude about the sequence x power n? Sequence x power n converges when mod x less than 1 and x is equal to 1, oscillates when x is equal to minus 1, and diverges to plus infinity when x greater than 1. So this is nature of the sequence x power n. Let us see the second standard sequence, which is n power 1 by n. The second standard sequence is n power 1 by n. Let n power 1 by n is equal to 1 plus hn. Take this substitution where hn is positive. Hn is greater than or equal to 0. Since n power 1 by n is equal to 1 plus hn, n is equal to 1 plus hn whole to the power n. Take this power to this side, then we get 1 plus hn whole to the power n. Again by binomial theorem, expansion of this is 1 plus nhn plus n into n minus 1 by 2 hn square plus etc plus hn to the power n. See, sum of these n terms is obviously greater than this term, third term, right? Here we have sum of n terms. This is obviously greater than third term. This is greater than n into n minus 1 by 2 hn square for all n. Now n is greater than n into n minus 1 by 2 hn square. n cancel ಆಯಿತು, ಎರಡು ಸೈಡು n cancel ಆಯಿತು. ಇಲ್ಲಿ ಎಡಗಡೆ 1 ಉಳಿದಿದೆ ಹಂಗಾದ್ರೆ. ಸೊ ಈ ಇನ್ಇಕ್ವಾಲಿಟಿ ಇಟ್ಕೊಂಡು ಏನು ಬರಿಬೋದು ನಾವು, hn ಸ್ಕ್ವೇರ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್, ಇದು ಈ ಕಡೆ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 2 ಇಲ್ಲಿಗೆ ಹೋಯ್ತು, n minus 1 ಇಲ್ಲಿಗೆ ಬಂತು, 2 divided by n minus 1 for n greater than or equal to 2. hn square is less than 2 divided by n minus 1. Now apply modulus, mod hn, take square root and apply modulus. We get mod hn is less than root 2 divided by n minus 1 for n greater than or equal to 2. Mod hn is less than root 2 divided by n minus 1, which is less than epsilon when n is greater than 1 plus 2 divided by epsilon square. Whenever n is greater than 1 plus 2 divided by epsilon square, root 2 divided by n minus 1 is less than epsilon. You can see that here. See, from this epsilon is greater than root 2 divided by n minus 1, which implies epsilon square is greater than 2 divided by n minus 1, which implies n minus 1 is greater than 2 divided by epsilon square. ಇದು ಈ ಕಡೆ ತಾಂಡಿದ್ದೀರಾ, ಇದು ಈ ಕಡೆ ತಾಂಡಿದ್ದೀರಾ, minus 1 ಈ ಕಡೆ ಕಳಿಸ್ತಾ ಇದ್ದೀರಾ. n is greater than 1 plus 2 divided by epsilon square. So whenever n is greater than 1 plus 2 divided by epsilon square, root 2 divided by n minus 1 is less than epsilon. So mod hn is less than epsilon for all n greater than 1 plus 2 divided by epsilon square. ಇವಾಗ ಏನು ಮಾಡ್ತೀರಾ, choose m which is nearer to 1 plus 2 divided by epsilon square and greater than 1 plus 2 divided by epsilon square. Let m be any positive integer greater than 1 plus 2 divided by epsilon square. Then for epsilon greater than 0, modulus of n to the power 1 by n minus 1, which is equal to mod hn. This is because, see, here we have take the substitution, n to the power 1 by n is equal to 1 plus hn. So ಈ hn ಜಾಗದಲ್ಲಿ ಏನು ಬರಿಬೋದು ನೀವು ಬೇಕಾದರೆ, hn ಜಾಗದಲ್ಲಿ n power 1 by n minus 1. mod hn is less than epsilon. That is nothing but mod n power 1 by n minus 1 is less than epsilon. Mod n power 1 by n minus 1, which is nothing but mod hn, is less than epsilon for all n greater than or equal to m. Now by definition, n to the power 1 by n goes to 1 as n goes to infinity. That is, limit n tends to infinity, n to the power 1 by n is equal to 1. As 1 is finite and unique, the sequence is convergent. Limit of n to the power 1 by n, limit of n to the power 1 by n is 1. So let us end here. Let us see the remaining two standard sequences in the next video.